from outside email IDs. Gaurav Prastagi, right? He's joining from another ID, and I don't want to let him inside. Okay. Okay. Live session started. Just a second. Okay.
Hello.
Yes.
Good evening, sir.
Okay. Good evening. Yes.
Sir, when we expect the result on the dashboard?
Which one? What do you expect?
The result on the dashboard?
Which result? Quiz 2.
Yeah, yeah.
I think it has been signed off. Tomorrow it should be there.
One more question, sir.
Yes, Gaurav.
In quiz one, good,
Hmm.
sir. Quiz one, I got 70%.
Okay.
So it's showing me already eligible for N term.
Okay.
So if in quiz two also I need to get some marks for that one, or is okay also?
So sometimes it is a weighted average between quiz 1 and quiz 2. If your quiz 1 mark is already high enough, sometimes you might be directly in. But
No,
let us
no,
wait.
yeah, yeah.
Hmm.
Because for me it is showing yes,
Hmm.
it's 70%. But
Okay.
for my friends, it is showing yet to be decided. That's why I got confused.
Okay. We will sort it out. By tomorrow, I think quiz 2 will also be updated, and then you will have a more concrete idea.
No, no, that's the thing. Because sir, in according to the grading document,
Hmm.
if you have more than 50% in quiz one and quiz two, it's okay.
Yeah.
So my quiz one itself is 70%, so it will not change, right?
Yes, it won't change definitely.
Oh, okay. That's why, because for my friend it is showing yet to be decided. That's why.
Okay. Okay.
One more suggestion, sir. Actually,
Hmm.
I posted on Discourse also
Okay.
regarding this one, because this time from 23 questions, 12 questions has been like
Hmm.
the answers have been changed.
Oh, there were some major corrections. Huh?
Yeah, yeah. 12 questions were changed suddenly.
It's changed in the sense I don't understand.
The answers got changed.
And maybe it was wrong answers and then updated. Are you saying that?
Yeah, kind of. It's updated, is updated. Like it's right or wrong, it's updated. So whatever was why right was become wrong, wrong become right.
Okay. I'm not able to understand what is right, what is wrong here. For example, let's say you have an answer. Let's say you have an answer, and the answer is, let's say you have a range from 69 to 70. This was the answer that was initially given, and then
Yeah.
let's say we upgraded to 72 to 73. This was the
Yes, yes,
initial.
yes. Kind of like that.
But which is correct? This is correct, or this is only correct?
Of course, the whatever that is correct is correct. Nothing you
Okay.
can change. That one I'm not arguing for that one, sir. That
Hmm.
is not the concern. What
Hmm.
I'm suggesting only, rather than having more subparts,
Hmm.
you can have more questions. So it will not be depending on the subparts for that one. Because if one subpart is changing,
Hmm.
the synchronize it is good. Other subparts also will change. So this way, students are losing more marks.
Okay. Hmm.
So it's like you can have more questions rather than having more subparts. You can have more questions
Okay. We
for
will.
the end term. Yeah, just a small suggestion only, because sir, what I'm seeing,
Hmm.
because for me, my in quiz two, I am having like in between whatever the earlier also my marks didn't change, because all my right become wrong and wrong become right.
Hmm. Okay. Okay. Hmm.
That's why. So it will
Got.
be very nice of you, and it's easy for your team also,
Hmm.
and it's easy for the students also, and for you are also, you can cover more area for the course, and
Sure.
it's easy for the students, why they don't have to depend on the one sub part. Okay, if one question is wrong, at least they can have the other one.
Okay. Sure. We'll consider that. We'll have these kind of discussions towards the end. Okay. Let's finish the
Yeah.
content that we wanted. Any more questions? Somebody raised their hand. What is it?
So, like the mail you have, the mail link which you have said,
Uh,
send in the G in the chat. It's
uh,
not opening. It's saying you are not a member.
Which one? The YouTube links that I shared on chat.
No, other than YouTube link which you have shared in the chat.
I have only shared YouTube link. I did not share anything else.
So like below, other one link is for YouTube and other link is for
Ah,
mail.
okay. Okay, okay. That is okay. I will share the correct thing. I think I shared the wrong one. Let me share the correct thing with you. I will share it towards the end. That was wrong.
Okay, okay, okay.
Mm, okay. So let's get started with conjoint today. We have a lot to cover. We also have to do little bit of DEA towards the end. Okay. So what is conjoint analysis? Did you look at the videos of conjoint? Else we will summarize quickly. Shall I quickly summarize conjoint analysis?
Yes, sir. Yes, sir. That will
Okay.
be good.
So it is a customer thinking process. So when you want to buy something, let's say you have multiple options, and please mute yourself. And if you have any questions, then unmute and talk. Okay. So let's say
Sorry,
you
sir.
have
Sorry.
no problem, no problem. Let's say you want to buy something, you have multiple options. Let's say you want to buy a car, right? The moment you, let's say you have a budget of 20 lakhs, right? So for this 20 lakhs, you want to buy few cars, buy one car, and you have a few options. So let's say you have Creta as one option, right? Then you have Volkswagen, right? What else you can think of, right? Maruti, our favorite. Okay. So which one you will decide, whether it is Creta or Volkswagen or Maruti, right? It depends. Creta could be very good in gearbox, right? Volkswagen could be very good in engine, right? Maruti's USP could be fuel efficiency, service, and so on, right? Each one is good in a particular aspect. Okay. So from the customer point of view, you have to you are basically depicting the customer's thinking process and mathematically modeling that. So we want to know how important is each attribute. So how much important is gearbox? How much is the engine given importance? Right? What is the importance of fuel efficiency? Right? So why do you want to know this? Why do you want to know what is the importance given to weightage? What is the importance given to gearbox? How much is the importance given to engine and so on? Right? What will you do with all these things? Right? With all these things, after knowing the customer's thinking process, can you build an ideal product? Can you build an ideal product? Right? That is what companies want to know. So to do this, you need to collect data. How will you collect the data? It has to be in a particular format. You have to collect data in two formats. One is ranking method, other one is pairwise comparison. What is pairwise comparison?
So like between
Hmm.
Creta and Maruti or
Hmm.
Creta and VW
Okay.
and all that combination.
Hmm. Okay. So let's come back to that. Okay. So pairwise comparison is like for engine, let's say the customer says, what does this mean? Let's say one is Hyundai, two is Volkswagen, three is Maruti. So if somebody mentions 1 comma 3, what does this means? The customer prefers 1 over 3. Similarly, if it is 2 comma 3, it is 2 over 3. Understood?
Yes.
Okay. So analysis of features considered jointly. You're not looking at one feature in isolation. You're not looking at the engine alone. You're not looking at the gearbox alone. We are modeling choices provided by the customer, right? We decompose all the preferences through relative values of the features, which means ultimately what are you trying to do? You want to, let's say there are some features, right? Engine, gearbox, fuel efficiency, cost, and so on. So for this each attribute, what is the weightage? So is it something like 20%, 15%, 30%, right? And so on. There could be n number of features. For each feature, what is the weightage that the customer is giving? This is what we are trying to understand through conjoint analysis. So there are different forms of conjoint analysis. What are the different forms of conjoint analysis? Choice based. What is choice based? Right? You give customer some 3-4 products, right? And then from these 3-4 products, you prefer the most preferred product. That is choice based. Next is adaptive. What is adaptive? Adaptive conjoint, right? Let's say a customer comes and he or she is very clear that they want a diesel engine, right? The moment you know that customer is looking for diesel engine, you will modify your questions accordingly, right? You will not bring in the petrol options at all. So second, let's say he or she wants an automatic gearbox. Your questions will not analyze all the options available. It will keep upgrading. It will keep updating based on the answers given by the customer. It is adaptive conjoint. Then what is menu based? What is menu based? Let's say you give customers some $100 of, let's say it's a gift that you give it to a customer. For this $100, you don't give it as a cash. You say to customer, well, you can select something like leather seats or air filter or ventilated seats. You already have seats. Huh? Let's take some other. You say alloy wheels. Right? For this $100, customer can either choose leather seats, air filter, air purifier, or alloy wheels. So based on whichever option the customer is selecting, you know that that particular attribute is more important for a customer. So by defining products as collection of attributes and having individual customers react to the available alternatives, we can understand few things. Right? What we can understand? Number one, most desired product. Desired product. Number two, most desired level. Okay, let's change it, rephrase it. I'm not happy with this wording. Importance of particular attribute. How important is gearbox? Okay. Number two is most desired level. What is most desired level? Let's say the fuel efficiency for Creta is 12 kilometers per liter. Right? Is this the most desired level? Then Maruti is let's say it's giving 15 kilometers per liter. So not just the importance of feature, the most desired level. Let's say Creta has 1.6 liter engine. Maruti has 1.5 liter engine. Volkswagen has 1 liter turbocharged engine, right? Whether this is more desirable, this is more desirable, or this is more desirable. You understand the importance of engine, and within that engine, which is the most desirable level. You understand all these things through conjoint analysis. So after understanding all these things, where will you use conjoint analysis? For what you will use conjoint analysis? Applications of conjoint analysis?
So market segmentation.
Market segmentation. Okay. You can use it in marketing, right? For example, if you see Tata Motors, right, they did heavy marketing on safety. Because of safety, they became market leaders in automotive segment, right? They started marketing on 5-star, 5-star, 5-star. All of their products had 5-star. They took marketing as their USP. I mean, they took safety as their USP and became market leaders, right? Tomorrow, let's say you're building a new product. You're building a new coupe type product. If you understand an ideal product, can you build one ideal product? So this can be used in product development, R&D. Right? Next, pricing. So you will be able to know, well, will customer pay extra for giving a more powerful engine? Will our customers pay extra if we give them leather seats and so on? Right? These are some of the applications of conjoint analysis. What is WTP? It is called willingness to pay. Okay. Now let's look at the let's say you have 4 products. You have 2 attributes, right? So now, what could be the pairs? Possible pairs? You can have something like 1 comma 2, right? 1 over 3, 1 over 4, right? Similarly for 2, similarly for 3, and so on. How many options or how many pairwise comparisons the customer has to do? If you have 4 attributes and if you have 4 products and 2 attributes, it is 4C2. You have 4 features and 2 attributes. How much it is? It is 6. So you will have 6 pairwise comparisons. Is it clear? You have 4 products and 2 attributes. So how many pairwise comparisons the customer will do? 6. Is it clear? Any questions?
No, sir.
Okay, good. And what is the, if you are collecting data in this pairwise comparison, what method you will use for solving the conjoint problem? Optimization approach. You will use linear programming to solve this optimization problem. And what is your objective function? You are trying to minimize the poorness of fit. What is poorness of fit? You have understood goodness of fit, but here we have something called poorness of fit. What is this? What is this? Violations. You want to minimize the violations. For example, if the customer says 1 comma 2, what does this mean? It is 1 over 2. 1 comma 3 is 1 over 3. Correct? Are you with me?
Yes, sir.
So sometimes when you ask a lot of questions to customer, the customer may not give you the correct answers, right? You are asking them, they are doing a favor by giving you some answers. It may not be correct all the times. They might make some mistakes. They might say, well, I like Volkswagen over Maruti's engine. I like Volkswagen's fuel efficiency over Maruti's fuel efficiency, right? Sometimes they might make mistakes. So those mistakes are nothing but violations. These violations are we are trying to minimize these violations. Is it okay? That is what we are doing in the optimization method. But what is more important is the regression method that we all know very well. Right? There is another approach which is called statistical approach. We collect data as ranking or rating. Okay. And we estimate betas, beta naught plus beta 1 and so on. What are these betas called? They're called part worth. What is part worth? Utility for that level of the product, right? For example, if you take uh, let's say you have Volkswagen, you have engine, right? You have 1 liter engine, you have 1.5 liter engine, you have 1.6 liter engine. So here engine power, right? Or you can take something like torque of the car, right? More the torque, better it is. Do you agree with me? More the torque, more the pulling power, better it is, right? So for upgrading an engine from 1 to 1.6, right? What is the worth the customer gets? That is part worth. We will see that in more detail, right? For now, this is what part worth is. Utility value for separate part of the product. Okay. So now let us go to this data, right? Here, professor has just a second, right? This is the same example that we have used in our lecture. Okay. So here we have 3 phone brands: Samsung, Vivo, and Xiaomi. Battery, we have 2 options: 4500 milliampere hour and 6000 milliampere hour. Camera, we have 3 levels: 20 megapixel, 13, and 18. So there are totally 18 options available to a customer. So it is like 3 into 2 into 3. So 3 brand options, 2 battery options, 3 camera options, total 18 options, and we have 18 options available. And what is your target variable? What is this? This is a rating. So higher the rating, better it is. Is it clear? Is it
Yes.
okay? Okay. So now this is, what type of variable is this? What are these variables?
Categorical.
Categorical variable. So there are 3 categories: Samsung, Vivo, and Xiaomi. Here there are 2 categories. Here there are 3 categories. So we have done coding, right? So Samsung is 1, Vivo is 2. What is number 2? Vivo is 2, Xiaomi is 3. Similarly, 4500 is 1, 6000 is 2. 8, 13, 20. 8, 13, and 20 are coded as 1, 2, and 3. Okay. Preference will be the same, no changes. So what is this? What is the difference between this and this? What are we doing here? What are we doing here?
So like in this for particular brand we are doing that first
Hmm.
6 option for that particular brand.
Okay.
Then,
This particular approach is called one hot encoding. Okay. So here, if you see, the first 6 rows are ones. Okay. So previously we had one column called brand, and under brand, what did we have? We have 1, 2, and 3. Right. This was the column manufacturer. Under this, we had 1, 2, and 3. So now what we are doing is, from the brand, from this column manufacturer, we are creating 3 columns, right? Samsung, Vivo, and Xiaomi. So here the first 6 rows were 1. So the first 6 rows will be 1. Rest all will be 0. This is our first brand. Okay. Now second brand, it will be 1 in the middle, right? This and this are 0. Similarly, the last brand, Xiaomi, will have ones here. Rest all will be 0. Is this clear? And why are we doing this? Why can't we have the column like this? What is the reason for
So,
doing this?
so in regression, like this is some sort of dummy variable that you are
Ah,
creating so
yes,
that you can get separately the beta values.
yes, yes, yes. Okay. Yeah, that is one option. Okay, that is correct. But apart from that, if you take 1, 2, and 3, 1, 2, and 3 will be like ordinal variables, because 2 is greater than 1, 3 is greater than 2. Do you agree with me? So what does this mean? Xiaomi is greater than Samsung, Samsung is greater than, I mean, Xiaomi is greater than Vivo, Vivo is greater than Samsung, and so on. So that kind of information is getting passed on to the model. Do you agree? We don't want ordinal variables. 1, 2, 3 is ordinal. Do you agree? We
Yes,
want
sir.
categorical variables. So that is why we make them into separate columns and we create this variable x1, x2, x3. Similarly, for battery, we create x4 and x5. For camera, we create 3 columns and do the coding, and the target variable remains the same. Right? This is the final coding. And if you see final coding, I have removed x1, I have removed x4 and x8. Why? Why did I do that? Why did I do that? I could have had all these 8 variables, right? So instead, what I am doing is I have only 5 variables or 6 variables. How many were there initially? X1, x2, x3, x8. Now I have only 5 variables. Why? I have removed one column from each and every variable. Each and every one from brand, one from battery, one from camera. Why?
Sir, in dummy variable, you take the base value as 0, and then others are
That is
given
fine.
as.
That is fine. But why did I remove Samsung here? Why did I remove 4500? Why did I remove 8 megapixel?
So dimensionality reduction.
Dimensionality reduction. Okay. So we do this to avoid multicollinearity.
Yeah, the features might be more collinear. So
Okay. So here, if you see this, if these two are 0, you know that it has to be the other variable, which is Samsung, right? Similarly, if your this variable, if this is 0, you know that the feature has to be 4500. You can figure that out. Similarly, if these two are 0, right, it has to be 1 for 8 megapixel. You already have a 1 here, right? Which means that the 8 megapixel column will be 0. When you have two features, you can figure out the third feature easily. So therefore, you will remove unwanted variables. What happens is when you have more features, what happens to your R square? More the
so
feature.
the R square will increase if it's adjusted R square, then it will increase if the features are contributing to the model.
Yeah, correct. So we don't want that. For that, we get rid of, to avoid multicollinearity, we use these features. Right? Options is not needed. It will not come in the regression modeling. And once we do the regression modeling, right, we get some metrics. Right? This is our R, multiple R, this is our R square, and so on. And what do we have here? The coefficients. Vivo, Xiaomi, the worth of battery, camera, and so on. So let's understand this. So this is 0. And why did I choose Samsung as 0? Why did I choose 4500 as 0? Why did I choose 8 megapixel as 0? And if you see in this final coding also, I have removed Samsung. I have removed 4500 battery. I have removed 8 megapixel camera. Why? Why? I could have removed Xiaomi. I could have removed 6000. I could have removed 13 megapixel. But why did I remove 8 megapixel? Why did I remove Samsung? Why did I remove 4500 milliampere hour? Right? Because those are the base levels. Right? So you have 3 cameras, 8 megapixel, 13 megapixel, and 20 megapixel. So this is their base level. Similarly, 4500, 6000 milliampere hour. Right? So which is the base level here? 4500 is the base level. Then you had 3 brands, Samsung, then Vivo, Xiaomi. So I have assumed Samsung to be the least rated brand. So So all these base levels I am removing. Okay, this is the assumption. I'm removing all the base level. Samsung is the least rated brand. That is my assumption. With that, I'm doing a regression, and therefore what I'm doing, I'm giving 0 to all these things. And why is Vivo 1.167? Why is Xiaomi 1.834? Because that is what we got from the regression analysis. 1.167, 1.833, 1.167, 1.834, 2.344, right? 2.344, 4.83 and 2.167, right? So what do we do next? We calculate something called range. What is range? What is range?
Min plus max divided by 2.
No, max minus min is called range. What you say is average, kind of average, right? This is
Yes,
uh,
yes.
not even average. So leave that, right? So max minus min is range. So here min is 0 everywhere, right? So therefore, what is the range? It is the max value. Okay, it is the max value. So this is your range, right? This is your range. So now let us understand what is the importance given to brand. This is nothing but this range of brand divided by sum of this plus this plus this, right? So let us reference these cells 4, 4, 4. Okay. So here this will be not C5. Okay. This will be right. Okay. So what I'm doing is I'm taking 1.834. Right. Let's understand the formula. This is the formula that I have used. C4 is this thing. I'm dividing 1.834 divided by the sum of all these three ranges. Similarly, here what I'm doing is I'm actually dividing 2.344 divided by the sum of all these ranges. Here I am dividing 4.834 divided by all these three ranges. If you add, it will add up to 100. So from my analysis, I understand the brand is 20% important, battery is 26% important, camera is 54% important. So the most important attribute of our cell phone is camera, according to this data. It could be different for different data sets. From this customer, whatever data we have collected, for him, camera is the most important attribute, followed by battery, and then brand. So tomorrow, if I build a new product for this customer, I will focus more on the camera, focus more on the battery, and then comes brand. Okay, this is what conjoint analysis will do. So to summarize, we have two types of data collection. Number one is pairwise. In pairwise, you collect data like 1/2, 1/3. It's pairwise comparison, and you use an optimization method. You use linear programming where you try to minimize the poorness of it, right? Whereas in the regression method, what you do is you collect data in this particular format, okay, where the target variable is in the form of rating, right? And your input variables are categorical in nature. Okay, this is how you collect the data, and then you run a regression analysis. From the regression analysis, what you do? You compute the part worth. So how do you interpret this? Right? If you upgrade the camera from 4,000 to 6,000 milliampere, right? 2.334, right? His part worth increases from his or her, the customer's part worth increase from 0 to 2.344. Similarly, if you upgrade the camera from 8 megapixel to 20 megapixel, the customer's part worth will go from 0 to 4.834. right? This is part worth. Is it clear?
Yes, sir.
Yeah. These are the important things that you need to know in conjoint analysis. So there is something that I missed out in the last class on data envelopment analysis. We will see that now, okay? And then we'll take more questions. Okay, this is an important question. This is available under week 9. If you go to practice assignment, right? This problem, right? So I will copy paste this problem on the chat. Okay. Right? We will try to solve this problem. So what are we trying to solve here? There are 6 business units, and note that it is 2 output and 1 input problem. Okay? 2 input and 1 input, and this input is constant. Okay, so output will say how efficient your business unit is. So the more the output, more efficient it is. Right? Input will be constant. Right? The 2 outputs, it will vary. These outputs will decide whether your business unit is efficient or not. You're trying to solve the optimization for business unit 3. If you go through the previous live session, you know that you have to solve a linear programming problem for each and every business unit. So there are 6 business units, which means you have to solve one optimization problem for business unit 1, one for business unit 2, one for business unit 3, all the way till the 6th business unit. For each and every business unit, you will solve one optimization problem to find out whether that business unit is efficient or not. Is it clear?
Yes.
Here, what they are saying is they have solved an optimization problem for business unit 3, and they found that the efficiency is only 0.7. What does this mean? What does this mean? It means the business unit is not efficient. It is only 70% efficient. And you find the dual variables corresponding to the constraints of business unit 4 and 5 are non-zero. What does this mean? The reference unit for business unit 3. This is the business unit. For this, business unit 4 and 5 are non-zero. Is it clear? Other business units are having 0 dual variable. The dual variable value is 0 for other business units. For example, 1, 2, and 6 have the dual variables as 0. Only for 4 and 5, you're getting non-zero values. These are the reference unit. So now you want to, okay, the dual variable values are also given. So it is 0.3 and 0.4. These are the non-zero values. Okay. So now you are given the following table, right? These are the reference unit 4 and 5. Now you want to find the number of sales in HCU3. How will you do it? Let's go to the Excel. Yeah. Let's go to the Excel. I'll try to solve this. Right. So we saw that the problem is solved for business unit 3, and it was inefficient. It was only having an efficiency of 0.7, and the reference unit for business unit 3 are business unit 4 and business unit 5. With this, you have to compute the sales of HCU3. How will you do that? How will you do that?
So like point 0.3 of sales of
Yeah.
BU4 plus sales
Okay.
of BU5.
Correct. Let's see whether you are getting the correct answer or not. Okay. So if you add this up, it will be 0.7. Okay. So what this gentleman says is, if you want to find the sales of HCU3, you will do 0.3 into 10,000 plus 0.4 into 8,000. Right? it is 6,200, correct? This is the answer. Let us go to this page and check the answers. Okay. So what is the answer given here? It is slightly different. This was not the answer that we got. Look at the answers. The answer is 8856 to 8858. But our answer is very different. That's because these two don't add up to 1. So what do? We have to normalize the coefficients. How do we normalize the coefficients?
0.3 divided by 0.7.
0.3 divided by 0.7. Similarly, 0.4 divided by 0.7. It's a long number, right? So when you have such numbers, what will happen? Okay, first let us solve this, and then we'll come back to this, right? I have a huge. I have not rounded off, but I have a long list going on. Let us try to do this first, and then we will change it. Okay. So now how will it look? It is equal to this value into 10,000 plus this value into 8,000. Okay. We have some answer, and if you add this up, are we getting 1? Right? We are getting 1. Sometimes this won't be 1. It will be 0.9999998, something like that. It will come. Okay. So now we have an answer of 8857.14. Right? Is it within this range? 8857.14. This is within the range. Right? But the major problem is rounding off. How many decimals do we have to check? This is a major issue. Some people will take 2, some people will take 4, and then finally we will have the discussion on discourse saying that, well, I'm only 0.1 away. Why don't you give me marks and so on? Lot of confusion will happen. So, what is the better thing to do? Do this 0.3 divided by 0.4. Right? Don't use the decimal value. Use the fraction value into 10,000. Okay. Okay. Have this here. Similarly, use.
Sir, it should be 0.3 by 0.7.
What did I do? Okay. 0.3 divided by 0.7. Correct. Similarly, do 0.4 by 0.7 into 8,000. What did I do? This. Okay. So now add them up. Okay. So right now we are getting same answers, but sometimes, right, this, if you add, it might not add up to 1. It might get somewhere like 0.998, something like that. So to avoid all those confusion, what you do? Use fractions. Right? You can never go wrong with fractions. Similarly, if you have to find the number of leads in HCU3, how will you do it? 0.3
Yes.
0.3 divided by 0.4 into 10. 0.4 divided by 0.7 into 12. Right? You will get the number of leads. So it will be somewhere between 10.8 to 11.4. Okay. This is again important. So if you look at when you get a question like this, you have to look at two things. Is it 2 output and 1 input, or is it 2 input and 1 output? You have to look at the question format. Second thing is, check if the dual variables add up to 1. If they add up to 1, you can directly multiply them with the actual variable and get the values in HCU. Okay. If they don't add up to 1, you have to normalize them and then do it. Is it fine?
Yes, sir.
Okay. So we have covered all the portions. So from my end, what I'm going to do is let me stop sharing and we will discuss few more things. So officially the live session is over, but we will stay for some more time and we will take questions. Okay, let me switch off the live stream. Okay, let me also stop the recording. Okay.